Hi, I'm an old guy and I do maths. And today we're looking at what the effect of this expression here inside a sine function is. So what effect does this have on a sine graph equation and obviously on the graph itself? Well, in order to do that, we need to consider what an ordinary sine graph looks like, and here we have one. Starting at 0 and running to 2 pi. Now we're going to assume all the way through this that we are dealing with a domain between 0 and 2 pi. Now, what happens when we do this? Well, the very short answer is that it picks up the sine graph and it moves it pi on 3 to the right. Now, this might look familiar to those of you who are acquainted with, say, for instance, quadratics. If you have something like x minus 2 squared, so that's x minus 2 all squared, that's in brackets, the effect of that on a quadratic is to move it 2 to the right. If you've got x plus 2 all squared, it moves it 2 to the left. And that is the case with this. If this were plus pi on 3, our graph would be picked up and moved to the left. Anyway, let's see what this looks like in practice. Now, you'll notice that I've drawn in some points on my next set of axes, and I've also drawn this little triangle from which we can calculate the value of the sine of pi on 3. So it is opposite over hypotenuse, so it's root 3 on 2. We're going to need that. Now, as I said, the effect of this is to take all the points on this sine curve and move them along the x-axis by pi on 3. So that's what I'm going to do. Now, the easy way to go about this is to figure out the points at which this will intercept the x-axis, and that's really straightforward, because if we move this point pi on 3, we get to here. If we move this point pi on 3, we get to here. We get to pi plus pi on 3, 4 pi on 3. And if the domain weren't restricted to 2 pi, we'd end up out here at 7 pi on 3, 2 pi plus pi on 3. Okay, so what does that mean? Well, the initial piece of artwork, if you can call my drawing that, is going to look like this. And if we continue this, what we're going to do is we're going to wind up somewhere here. And we're going to need to calculate that point. Now, just as we do over here with this point and this point, if we could see it being moved to the right, the inevitable result is that our graph actually starts somewhere here, and we need to calculate that point. So we know that the normal value of pi on 3, the sine of pi on 3, is root 3 on 2. Now, had we been able to continue this graph over here to negative pi on 3, the value that we would have got, and this is not to scale, the value that we would have got is negative root 3 on 2, which is approximately 0.8 something. It's close to 1. So this point down here is negative root 3 on 2, and surprise, surprise, so is this point here. negative root 3 on 2. And we simply calculate that by finding the normal value of the sine of pi on 3, and just remember that we have moved this by that distance to the right, and so this value here, when we put 0 into this, we are looking for the sine of negative pi on 3, which is another way of thinking about this entirely. Well, what's the sine of negative pi on 3? What's the negative sine of pi on 3 is another way of looking at that, and that is root 3 on 2. And that's our value there. We've got all the intercepts that we need. We can also work out points of interest on here if we wish to. It is simply a matter of taking into account what's gone on here. Okay, now I hope that was simple and straightforward to understand. If you found it useful, please like and subscribe, and I'll see you on the next video. Thanks very much. Bye.